ही हैं और फिजिकली मैम ने अपना लेक्चर दिया था जो मतलब यहाँ के जो पार्टिसिपेंट्स थे और स्टूडेंट्स थे सभी को बहुत ही अच्छा लेक्चर रहा था मैम का, इंटरेक्टिव सेशन जिसको कहना चाहिए। और आज भी मैम कुछ ऐसा ही लेके आई हैं, लेकिन अनफॉर्चुनेटली मैम की तबीयत अचानक से खराब हो गई तो मैम आ नहीं पाई हैं। तो फिर हमने ऑनलाइन इसीलिए मैम से बोला कि आप ऑनलाइन ज़रूर दें एटलीस्ट। तो उससे पहले कि हम स्टार्ट करें, मैं मैम का ब्रीफ इंट्रोडक्शन देना चाहूँगी। जो लोग इस बार हमारे साथ कनेक्ट हुए हैं, उनके लिए। मैम इज़ BA ऑनर्स, MA, MPhil, PhD, and then there are so many publications are there. Uh, Around in 2022, there are 5 Scopus research publication of ma'am in reputed international or national journals. In 2021, again, there are 7 to 8 papers और ऐसी बहुत लंबी लिस्ट है। तो मैं अगर इसको फिलहाल छोड़ दूं, then there are 4 books which has been published by ma'am. मैम हैज रिटन दिस। कॉन्फ्रेंस वर्कशॉप्स मैम ने बहुत सारी अटेंड की हैं, उनमें बहुत सारे लेक्चर्स मैम ने वहाँ दिए हैं। पार्टिसिपेटेड इन ICT वर्कशॉप ऑल्सो, और बहुत सारी चीज़ें हैं। क्योंकि अगर मैम का CV पढ़ने के लिए यहाँ पे खड़े हो जाएँ तो इतना लंबा है कि मुझे लगता है कि अभी इसी में टाइम निकल जाएगा। तो मैं बहुत ज़्यादा टाइम ना लेते हुए और मैम का एक ब्रीफ इंट्रोडक्शन, इसीलिए मैंने कहा कि ब्रीफ इंट्रोडक्शन दे दें। वैदिक मैथमेटिक्स में मैम का बहुत इंटरेस्ट है, मैम उस पे काम करती रहती हैं। हमारे साथ में कुछ रिसर्च पेपर भी मैम ने लिए हैं। वो जो हमारा रिसर्च जर्नल आ रहा है उसमें बहुत ही जल्दी पब्लिश हो भी चुके हैं और होने वाले हैं। तो मैम थैंक्स फॉर कनेक्टिंग विद अस, और ऐसे ही आप जुड़े रहें और आपके लेक्चर्स हमें सुनने को मिलते रहें, कुछ नया सीखने को मिले। जैसा कि हम सभी को पता है, नेशनल वर्कशॉप पे हम यहाँ पे बैठे हुए हैं सभागार में, न्यू डायमेंशंस इन वैदिक मैथमेटिक्स। तो जो लास्ट लेक्चर हुआ था, अब उसी में मैम ने जो आप अपना टॉपिक लिया है कैलकुलस की एप्लीकेशंस, मींस जो वैदिक मैथमेटिक्स की एप्लीकेशन को कैलकुलस में कैसे लगाया जाएगा, वो मैम आज लेंगी। तो मैम प्लीज ओवर टू यू।
फर्स्ट ऑफ ऑल थैंक यू सोनिया जी। आई एम सॉरी, थोड़ा सा मेरा गला खराब है तो थोड़ी आप लोगों को दिक्कत हो सकती है, बट ट्राई करती हूँ। फर्स्ट ऑफ ऑल आई वुड लाइक टू थैंक डिपार्टमेंट ऑफ मैथमेटिक्स, चौधरी चरण सिंह यूनिवर्सिटी फॉर गिविंग मी दिस अपॉर्चुनिटी।
मैम जहाँ आप बैठे हुए हैं लाइट का बहुत ज्यादा रिफ्लेक्शन आ रहा है, तो पोजीशन थोड़ा सा अगर यस 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 दैट विल बी बेटर। थैंक यू।
तो दूसरा शिवराज जी का बहुत बहुत धन्यवाद कि उन्होंने मुझे फिर से बुलाया और मैं अपनी जो भी थोड़ी बहुत नॉलेज है वैदिक गणित की वो आपके साथ शेयर कर चुका हूँ। लास्ट वर्कशॉप में हमने क्या किया था कि जितने भी जो हमारे एडिशन, सब्ट्रैक्शन, मल्टीप्लिकेशन, डिवीजन है, जो 16 सूत्राज हैं और 13 जो उप सूत्राज हैं, उनको अप्लाई करके कैसे कैलकुलेशन फास्ट की जा सकती है वो हमने किया था। Now I am sharing my screen. Is it visible? Screen is visible?
Yes, ma'am.
Okay. See, in algebra, basically we study 4 operations: addition, subtraction, multiplication, and division. In these operations, if we apply the concept of limit, it becomes calculus. And in calculus, we start from finding the limit of a function, and then we move towards continuity. And applying this continuity, we move towards the differential calculus and then integral calculus. Basically, differential and integral calculus, these are the applications of limits. So let me start with this, that if you have function y is equal to fx, this x is independent variable and y is dependent variable. So what is the derivative? We make a change in the slight change in independent variable, it becomes x plus delta x. Then the corresponding change in the value of y, the dependent variable, is y plus delta y. If we just subtract, what we are getting, that we are getting delta y is equal to f of x plus delta x minus fx. We divide this with the change in the independent, and then we take the limit as delta x tends to 0, delta x tends to 0. So what is this? This is basically dy by dx, and this is f dash x. So what is derivative? Derivative is basically the rate of change of dependent variable with respect to the rate of change in the independent variable. It has beautiful applications in our day-to-day life, that if you are moving in a car and you want to you have displacement, that you are moving from one place to another. So the rate of displacement with respect to time is nothing but velocity. Similarly, the rate of change in velocity with respect to time is nothing but acceleration, and so on. If suppose you want to buy 10 items for 100 rupees and the 11th item for 105. So there is a change in the price. So this is a change in cost. So in this way, we can find out by taking the derivative, we can find out this marginal cost. So we have so many applications in our day-to-day life. So today, I'm going to take this, that how do we use Vedic mathematics, and we have shortcuts for finding the derivative of a function, higher order derivatives, and integral calculus also, if I'll get time. So first is that we have some basic formula for derivative. You must know before proceeding. You already know, I know. This is n x raised to the power n minus 1. We bring this power here and subtract 1 from the power. Then derivative of e raised to the power x is e raised to the power x. Derivative of log x. These are the basic we need to apply the Vedic mathematics. This is 1 upon x. Derivative of sin x is cos x. Derivative of cos x is minus sin x. Derivative of tan x is secant square x. Derivative of secant x is secant x tan x. Derivative of cot x is minus cosecant square x. Derivative of cosecant x is minus cosecant x cot x. So these are the basic, and I think all of you are familiar with this. Now towards finding the derivative of a composite function. What do you mean by composite function? Composite function is that function of function. That if we have two functions, f and g, we can find out composition of this, that f of gx, this is nothing but f of gx. When we talk about its derivative, then its derivative means that we need to apply the chain rule. This is f dash gx, and there is a chain. Inside we have this function. This is g dash x. But in Vedic mathematics, how do we find? For this, we use the sutra. This is Urdhva Triagabhyam. Means vertically and crosswise. Now, for example, if suppose I say, find the derivative of sine of 4x plus 5. This is basically the composition of two functions. First function I can define f1x as, or fx as sine x, and gx as 4x plus 5. If I find out f for gx, so what exactly is this? This is f of 4x plus 5, which is same as sine of 4x plus 5. So this function, this is nothing but the composition of two functions. So obviously, we need to apply chain rule. So sometimes when we check answer scripts of the students, of undergraduate level students, sometimes they forget to take this derivative. But when you apply this Vedic Sutra, vertically and crosswise, you won't forget. So do we do it? So what we do, we write here first function sine 4x plus 5. So here the first function is sine. And what is the derivative of sine? It is cos 4x plus 5. And what is the second function? It is 4x plus 5. And what is the derivative of this? It is only 4 because 5 is constant. And now we need to multiply vertically. So what is the derivative of sine of 4x plus 5? Just it is 4 times cos 4x plus 5. See, it is simple. Chances of mistakes are less. Shall I erase? सोनिया जी erase कर दो.
Yes, ma'am. You can erase.
Suppose you have sine of 10x square. Here, this is composition of 3 functions. One is sine, another is 10, and the third one is x square. So what we do? We write here sine of 10x square. Only take the derivative of the first. It is what? This is cos of 10x square. What is the second function? 10x square. And just differentiate this. Its derivative is secant square x square. What is the third function? This is x square. So we write this to be 2x and then we multiply vertically. So what is the derivative of this? Sine of 10x square. This is going to be 2x secant square x square into cos of 10x square. So you can see the chances of making mistakes are less. Now, sometimes we have this function log of say sine x. This is composition of 4 functions. Okay, so we take one by one. First is log sine x. And what is the derivative of only first? Log x, derivative is 1 by x. So it becomes 1 upon log sine x. Come to the next. So next is log of sine x. Only differentiate this log. So it is 1 upon log of sine x. Come to the next. So this is log of sine x. Now what is the derivative? 1 upon sine x. And next sine x. What is the derivative? Cos x. Just multiply, start from down to up vertically. So the derivative of log sine x, which is cot x divided by into 1 upon log sine x into 1 upon log sine x. So see, it has made the calculations simpler and quicker. Now next we move to the product rule. If we have the product of 2 functions, say fx and gx, and you want to find out its derivative, obviously, what is the product rule? This is f dash x, derivative of the first function, into second function, plus first function into derivative of second function. See, we can write this as fx and gx here. This is f dash x, g dash x. You just multiply like this, crosswise. See what you are getting. F dash x into gx, fx into g dash x. Again, vertically and crosswise. So this formula is applicable. Now, for example, if suppose I say that find the derivative of x square sin x. So you write 2 functions separately. This is your fx, this is your gx. This is fx, this is gx. So your gx is sin x. When you find the derivative of the first, it is 2x. When you find this derivative of the second, it is cos x. You just multiply crosswise. So what is the derivative of this function? X square sin x. This is nothing but 2x sin x plus x square cos x. See how simple is this? Shall I erase this?
Yes, ma'am.
Now, if I take composition and the product both, I have just told you 2 methods. One is the derivative of the composition and second is the product. If suppose I have both, suppose I say find the derivative of x cube log cos x. So this is a composition of two functions, log x and cos x. And this is another function, okay? So what we do, we write here x cube, and here we write log cos x. And because in composition also, we write like this. So what is the derivative? This is 3x square. And here, log cos x means 1 upon cos x, because we only differentiate this. And the derivative of cos x is minus sin x. And for this, we use this vertical, and for this, we use crosswise. So what is derivative? Directly you can write the derivative of this is nothing but 3x square log cos x and plus x cube into minus 10x. Okay. Now this is only the first derivative. You can ask me this question. Can we find out the higher order derivatives, second order, third order in one line? We basically, if the first derivative is continuous, we can move towards the second derivative. If second derivative is continuous, we can move towards the third derivative. But we move step by step. First we find first, then second, then third, and then fourth, and so on. But using Vedic Sutra, you can in single one line find third derivative, fourth derivative, fifth derivative, whatever you want. But before this, I just want to explain you the Pascal's triangle. Or using this, we can have, this is higher order derivatives. And using this, we will find out the differential coefficient. We need this Pascal's triangle, or in Vedas it is known as Alliance Meru Prasthar. What is this? That if we have D0 means function. Whatever function is given, it is denoted by the zeroth derivative, function itself. And its coefficient, differential coefficient is 1. When we find D1, the first order derivative, this is first order derivative, it is 1 and 1. Basically, it is 0 and 0. So 0 plus 1 is 1, and 1 plus 1, 0 is 1. So that is why we have this. Second order derivative, this is 1. Then 1 plus 1 is 2. And then we have 1. For third order derivative, this is 1. 2 plus 1 is 3. 2 plus 1 is 3. This is 2 plus 1 is 3. 2 plus 1 is 3. And then 1. Fourth order derivative, it is 1. 1 plus 3 is 4. 3 plus 3 is 6. 3 plus 1 is 4. And then 1. And you keep on moving like this. So this is a triangle type of thing. That is why it is known as Pascal's triangle. And we are going to make use of this in second order, third order, fourth order derivatives. And in single line, you will get all. Shall I erase this?
Ma'am.
If suppose the question is, find the second order derivative of, x raised to the power 4, e raised to the power 2x. See, how do we apply this Pascal's triangle? We first write down here, because this is the product of two functions. So we write two functions, x4. The second function is e raised to the power 2x. We want to find out up to second derivative. We differentiate these two separately up to second derivative. So what is the first derivative? It is 4x cube. What is the second derivative? It is 12x square. Similarly here, e raised to the power 2x, its first derivative is e2x. The second derivative is 4e2x. Okay. Then If you just see the Pascal's triangle, what were the coefficients? The coefficients were 1, 2, 1. Write on the coefficients below it. This is 1, 2, 1. And how do we write the answer? We just cross multiply like this and this with the help of these coefficients also. So how do we write the answer? The answer would be 4x raised to the power 4. इसको इसके साथ और इसका कोएफिशिएंट क्या है 1. So we have x4, 4x4 e raised to the power 2x. Then second is this is 2 and we have to multiply like this. So it becomes 2 times 4x cube plus into 2 times e raised to the power 2x. This is the second term. And what is the third term? And its coefficient is also 1. So this is 12x square e raised to the power 2x. See, in one line we are getting the answer, the second order derivative. Okay, any doubt? Shall I erase this?
No doubt, ma'am.
If suppose you want to find out third derivative of x raised to the power 5 e raised to the power 2x. Okay, so same technique we adopt. We have x5 e raised to the power 2x. So we want third derivative. We differentiate both the functions separately up to third derivative. This is 5x raised to the power 4. This is 20x cube, then 60x square. This is the third derivative. Similarly, this is 2 e raised to the power 2x, 4 e raised to the power 2x, 8 e raised to the power 2x. And what about the coefficient for third derivative in Pascal's triangle? These were 1, 3, 3, 1. And how do we multiply? We multiply like this and last, and here also cross. We have this crosswise. Okay, and along with the coefficients. So first is x5 with the last one and its coefficient is 1. So what is the answer? 8x raised to the power 5 e raised to the power 2x. Second is we have this, but its coefficient is 3. So we multiply by 3. This is 3 into 5x4 into 4 e raised to the power 2x. Next is we have this and its coefficient is also 3. So this is 3 into 20x cube into 2 e raised to the power 2x. And the last one is this one and its coefficient is 1. So it is 60x square into e raised to the power 2x. See, in one line, we have got the third order derivative of this function. Whereas in usual method, you have to do this in 3 steps. So it is quicker than the normal method. Now next comes the quotient rule. I mean, when you function the fraction of two functions, fx divided by gx. If suppose you want to find out the derivative of the quotient of the two functions f and g of this form. So what is the formula for this? That we take the square of the denominator and in numerator we have f dash x into gx minus fx into g dash x, right? If we just observe the numerator is same as the previous case except the minus sign in between. So what we do, we also use the same technique. Suppose I say that find the derivative of cos x upon 1 plus x square. So we write here cos x and 1 plus x square. This is your fx and this is your gx. So what we do, we find the derivative. Its derivative is sin x and its derivative is 2x. So, but here you have to take one thing in your mind. First is the derivative of f. So it means you have to first take this. This is first one. And then with the minus sign, this is your second one. Okay. So the answer here will be 1 plus x square into minus sine x with a minus sign, 2x cos x, and take the square of the denominator. That's it. So quickly you can write the answer. Now, if suppose you need to find out the derivative of x cube minus 1 divided by under root of x square plus 1. So here your fx is x cube minus 1 and gx is under root of x square plus 1. Its derivative is 3x square and its derivative is 1 by 2 under root of x square plus 1 into 2x. Apply that chain rule. So what is the answer? It is going to be 3x square into under root of x square plus 1 minus times x upon under root of x square plus 1 into x cube minus 1 divided by x square plus 1. See how quickly we can write the derivative in case of this quotient when we have division of 2. Okay. Now, as we were moving towards the research, I'm giving you one research problem that you develop a formula for finding the higher order derivative in case we have this quotient function. This is the research problem now, if you can try. Now let us move to the integral calculus. Here we have a few interesting things in integral calculus. Integral is basically the inverse process of differentiation. Here also you need to know some basic integrations. You know, the integration of x raised to the power n is x raised to the power n plus 1 divided n plus 1 plus a constant of integration. Then integration of cos x is sin x plus a constant of integration. Integration of sin x is minus cos x plus this integration of 1 by x dx. The basic things you know, already know, all of you. Integration of e raised to the power dx. This is e raised to the power x plus c. Others we can make out using the this Vedic sutras. Now, if you have simple addition, means you integrate x raised to the power 4 plus 2 e raised to the power x plus sin x dx. It's simple that you put integration along every term in case of sum and you find out x5 by 5. This is simple. So no use of any Vedic sutra, cos x plus c. But when we have product, then obviously we use by parts. And sometimes students, when you apply it by parts, they make several mistakes. So for this, there are formulas in using Vedic mathematics, and these are very simple. So for example, we have that you integrate x square log x. Basically, this is the product of two functions, fx and gx. If you remember, when we integrated by parts, we need to identify the first function and the second function. For first function, we use this ilet. Here also we need to use ilet. I for integers, L for log, arithmetic, algebraic, trigonometric, and exponential. In this way, we choose the first function. So using ilet, we choose the first function. If suppose this is first function, this is second function. So what is the formula? First function as it is, integral of the second function minus derivative of the first function into integral of the second function and dx. This is the formula. Okay. But in Vedic mathematics, again, we use the same vertically and crosswise. And it is simple. First, you identify which one is the first function. Because if you just see first function का derivative लेना है, we have to differentiate the first function. So that is why we need to do this. So first is the integers. Log. Here log is coming. So we have that this is the first function and this is the second function. So in the same order we write, here we write first function, here we write second function. So it is your log x and it is x square. और first function को क्या करना है? Differentiate. So you need to differentiate the first function and you need to integrate the second function. So what is the derivative of the first function? It is 1 by x. So you write 1 by x. But you need to integrate the second function. So it is x cubed by 3. So what we do, that we use this and then we use this crosswise and vertical. And we put a minus sign in between. So how do we write this answer? This is going to be log x into x cubed by 3 minus, and then 1 by x into x cubed by 3. So we have minus 1 by x into x cubed by 3 dx. So it becomes x cubed by 3 log x, and this cancels. So it is x square. X square is again x cubed by 9 plus constant of integration. So see how simple is this? Let me take a complicated one. Shall I erase this?
Yes, ma'am, it is clear. कोई doubt?
Any doubt है तो?
नहीं, ma'am. Everything.
Now suppose you want to integrate. Am I fast? I can be slower.
It's okay.
Okay. If suppose this is x raised to the power 4 cos x. So here the first function is this x4. So this is first function, this is second function. Okay, so what we do, we write here first function, here we write the second function. So we have to differentiate this function until we get 0. Okay, so we have this is 4x cube, next is 12x square, then 24x, and then 24 and 0. And for this we differentiate, we integrate cos. So integration of cos is sin x. Integration of sin x is, you have to keep this thing in mind that first function is to be differentiated and second function is to be integrated. ये ध्यान रखना पड़ेगा. Integration of sin x is cos x. Integration of cos x is again sin x. Integration of sin x is cos x minus cos x, and cos x is sin x. And we stop. Now we have minus sign also in between when you apply by parts. So alternatively what we do, that we put a plus minus sign. So here will be plus sign, then we have minus sign, then we have plus sign, then minus sign and plus sign. How do we write the answer? Answer would be that we have to multiply like this, keeping in mind the sign also. And then in the last, we will have vertical. So what is the answer? Answer is going to be, the first sign is plus. So this is going to be x raised to the power 4 sin x. Here we have a minus sign and this is also minus sign. So this is going to be minus minus plus 4x cube cos x. The next term is plus sign, but this is minus. So it is minus 12x square into sin x. The next is minus 24x into cos x. Next is 24 into sin x. And we need to multiply vertically. 0 into sin x is 0. So see that otherwise it would have taken, because it is x raised to the power 4. So to reduce it to, every time you need to reduce the derivative. So you need it 5 steps. But here you are doing this in 1 step. I hope this is clear.
Yes, ma'am. Fine.
If both the terms are one trigonometric, one algebraic, then obviously you can select. If suppose both terms are algebraic, so what you do in this case? So it's better to take a simpler term so that after some derivatives, it will come out to be 0. So here, let us take this to be the first function and this to be the second function. So it is x cube. This is x plus 1 raised to the power 4. So we have this is 3x square into, and this is 6x. Then we have 6 and then 0. We integrate. Here we have to differentiate this, integrate. This is going to be x plus 1 raised to the power 5 divided by 5. X plus 1 raised to the power 6 divided by 6 into 5. Directly you can take 30. X plus 1 into raised to the power 7. This is 7 into 6 into 5. Then x plus 1 raised to the power 8. This is 8 into 7 into 6 into 5. And we have to take alternatively plus sign, minus sign, plus sign. Let us write the answer. So we need to multiply like this. It is important to draw these diagonal lines. And in the last, we have this vertical. So what is the answer? Answer is going to be x cube into x plus 1 raised to the power 5 divided by 5. Here we have minus sign. So it is, you can cancel out this 3 with this. So it is x square by 10 into x plus 1 raised to the power 6. You can cancel out this 6, next is plus. So it is x into x plus 1 raised to the power 7 divided by 35. Then we have minus sign. You can cancel out the 6. So it is going to be x plus 1 raised to the power 8 divided by 280 and plus 0 plus the constant of integration. Okay.
Yes,
Now
ma'am.
let us-
Ma'am,
Mhm.
if it will be a definite integral, then just we have to put the limits.
Yes,
Rule is-
yes. हाँ,
Rule is the same. Thank
you
you.
can do ना कि लिमिट्स हैं तो वहाँ पुट कर सकते हैं.
Right.
Then the c won't be there. Constant of integration. Okay. Next is the partial fractions. Making partial fraction is a difficult task sometimes. So we have, how much time is left with me? Then only I can take up. Because if I have to wind up it by 3, then I have only 4 minutes to left. 4 minutes are left. Sonia ji?
Ma'am, 10 minutes.
Okay, then I can take. Thank you so much for giving this time. Okay. So we have partial fractions. Integration by partial fraction. Basically, we deal with 4 types of partial fractions. First is non-repeated. If these are non-repeated factors, means the function is of the form fx divided, and these are linear also in the denominator. Non-repeated linear factors, I can say. So we can write this to be a upon x plus b, x plus a plus b upon x plus b. And if you have more, then we have more. Similarly, if we have repeated linear factors, I'll give you a shortcut of finding all these types of things if I'll have time. Fx upon, say we have x plus a whole square, x plus b type of thing, that this is repeated twice. So how do we write this? This is a upon x plus a plus b upon x plus a whole square plus c upon x plus b, and we have so on. Then we have non-repeated quadratic factors. So in this case, we have fractions of the type ax square plus bx plus c, and then we have say px square plus qx plus r. Because it is quadratic, so here in the numerator we take ax plus b divided by ax square plus bx plus c plus cx plus d divided by bx square plus qx plus r. Next type is repeated quadratic factors. So your function is of the form ax square plus bx plus c whole square, px square plus qx plus r, and so on. So in this case, we have this is ax plus b divided by ax square plus bx plus c, and then cx plus d divided by its repeated factors c whole square, and then we have ex plus f divided by the next px square plus qx plus r. So in this way, we make the partial fractions, and this thing you all know. But using Vedic sutras, how do we find in shortcut the values of these constants a and b, so that a, b, c, etc., so that you you can integrate the function which is of the form, sorry, you can integrate the function using partial fractions. Now, for example, if your question is that you integrate x upon x square plus 5x plus 6. So 5 can be divided in two parts, 3 plus 2 by dividing the middle factor. So obviously this is going to be x dx divided by x minus 3 x plus 3 x plus 2. Okay. So this function can be written as a upon x plus 3. Next line. It is x plus 3 x plus 2. This can be written as a upon x plus 3 b upon x plus 2. So normal way what you do, that you you take LCM and then you put x is equal to minus 2, x is equal to minus 3, and then find the value. But what we do, that here below a we have x plus 3, right? So we remove this x plus 3 from here. So what exactly you have? This is x upon x plus 2. And in this, you put x is equal to minus 3. So this is going to be what? Minus 3 divided by minus 3, 2. So it is going to be 3 only. So this is the value of a. I hope you are getting this point. That below a you have 3. You remove it from the function and then put this value in the function. Directly you can have the value of a. Similarly, below b, you have x plus 2. You remove this factor. So you have this is x upon x plus 3. And substitute here x is equal to minus 2. So this is minus 2 divided by 1. So it means the value of b is minus 2. So see, quickly we can find out. I mean, by observation also you can directly find out. So this integration, this can be directly written as, this is 3 upon x plus 3 dx and minus 2 upon dx upon x plus 2, which is going to be 3 log x plus 3 minus 2 log x plus 2. So this is the simplest one, the first one, which we have obtained. Any doubt?
No, ma'am.
मैम आपने डिनोमिनेटर को 0 के इक्वल रखा है ना, मतलब x + 3 = 0, x + 2 = 0 करके।
हाँ हाँ, वहीं से तो फैक्टर आएगा, उसकी वैल्यू वहीं से
हाँ
आएगी।
जी, हाँ जी।
Let me take one more question so that you will have a clarity. If suppose you have this, that you integrate 5x minus 11 divided by 2x square plus x minus 6. You integrate this. So when you make the partial fractions, so this is basically coming out to be, I'm writing it directly. So you can write this to be a upon x plus 2, and this is 2x minus 3 if you make the partial fractions. So from here, below a, it is 2. So value will be minus 2. Okay. So this can be written as 5x minus 11 divided by x plus 2. And this is 2x minus 3. So what is the value of a? A is going to be, you need to substitute x is equal to minus 2 in this portion. So directly I can put, when you put x is equal to minus 2, it is going to be minus 10, minus 11, minus 21 divided by minus 2, 2s are 4, minus 7. So it is 3. So how quickly you can find the value? Otherwise, it takes time. Similarly, for x is equal to, below b, it is 2x minus 3. So value of x is 3 by 2. So here, you need to put x is equal to 3 by 2. So what is the value of b? It is 5 into 3 by 2 minus 11 divided by 3 by 2. 3 by 2 plus 2. So it is 15 minus 22. It is minus 7. And this is going to be 437. It is minus 1. So you put integration. So basically it reduces to x plus 2 dx minus dx upon 2x minus 3. So you can find out this is log of x plus 2. This is log of 2x minus 3 divided by 2. So see, that easily you can find out. Now next is when we have repeating factors. Now, when you have repeating factors, suppose you have that you integrate 3x plus 5 divided by 2x minus 1 whole square. So this function, this can be written as, when you have repeating factors, ax divided by 2x minus 1, b upon 2x minus 1 whole square. The first one is easy. When removing this, when you put x is equal to half, x is equal to half, you will get the value. Because you can see that this can be written as 3x plus 5 is equal to a times 2x minus 1 plus b. So in the numerator, basically I'm telling you that when we have repeating factor, and it is coming here or here. So both we are getting x is equal to half when you get. So obviously denominator will give you infinity. So we have to, in this case, to get the value of b, where you have this maximum power, the value of b will be that you substitute x is equal to minus half, x is equal to half only in the numerator. So this is going to be 3 into half plus 5. This is going to be 13 by 2. But what about the second one? For the second one, what you do, that you take the derivative of this. When you take the derivative of this, you are getting this to be 3 is equal to 2a. You just differentiate this. So you have 3 is equal to 2a. So the value of a is going to be 3 by 2. Simple. Instead of comparing the coefficients and all, and if suppose it is cube, then you have to take, you will have 3 plus c also, you have to take derivative twice. So by using the derivative concept, you can find out this value. and then integrate it. If suppose you have the quadratic factors, then how do we simplify it? If suppose you have that.
Yes, ma'am, we have to conclude because
Okay.
next speaker.
Thank you so much for giving these 10 minutes. I hope you enjoy the lecture.
Thank you so much, ma'am. Such a wonderful lecture again. आपने जो पहले लेक्चर दिया था वो भी आई ओपनिंग था और ये लेक्चर भी आई ओपनिंग है। जैसा आपने डिफरेंशियल कैलकुलस, इंटीग्रल कैलकुलस, इन सारी चीज़ों को मर्ज किया है ऊर्ध्वतिर्यक के साथ में। अभी तो एक सूत्र का जिक्र किया है, अभी पता नहीं कितनी सारी चीजें हैं जो इसमें उजागर होनी है। अभी मैं इनवाइट करना चाहूंगी एचएन सिंह सर को फॉर वोट ऑफ थैंक्स फॉर दिस सेशन। सर प्लीज कम।
Thank you so much. I thank from bottom of heart to Dr. Anuradha Gupta. And today I came to know that why research is written after search. RE is written because once we go through the derivations, the steps are there. But once we go the research of that derivation, then these tricks are going to reappear. Rather than solving every time such steps, we can write the terms in a very simple fashion. So today we have just gone one aspect of ma'am's skill, problem solving. But ma'am is expert in collaboration, adaptability, critical thinking, strong work ethics. And from this strong work ethics, I remember that at one place Einstein has quoted, even he got every name and fame in this world after getting Nobel Prize, that as long as I am able to work, I must not and I will not say excuse, because work is the only thing which gives substance to life. Then ma'am has skill in leadership, time management, handling pressure, hard working and focus. So in coming workshops, seminar and such conferences, we will be privileged to get these ability also from ma'am. So thank you so much for this novel lecture to us. Thank you, ma'am.
Ma'am, thanks a lot.
Thank you, Shuraji. Thank you so much.
और फिर से
बिल्कुल।
कॉन्ग्रेचुलेशन आपको प्रोफेसर बनने के लिए, बहुत
जी,
बहुत
जी,
कॉन्ग्रेचुलेशन डिपार्टमेंट ऑफ मैथमेटिक्स। आपकी गाइडेंस हमेशा अवेलेबल रहती है यहाँ पे, और बहुत ज्यादा मैं देख रहा था कि बच्चे लगातार कैलकुलेशंस कर ही रहे थे, डिफरेंशियल इंटीग्रल सारी। तो वेरी मच इंटरेक्टिव लेक्चर, थैंक्स अ लॉट मैम।
थैंक यू सो मच। मैं आना चाहती थी पर मैं क्या करूँ, मुझे
आप रेस्ट कीजिए, वो ज्यादा
टाइफाइड
जरूरी
हो गया।
हाँ, डॉक्टर सोनिया ने। फिर मुलाकात होगी मैम।
जी, जी, धन्यवाद।
प्लीज टेक केयर ऑफ योरसेल्फ। और
Thank you.
मैं एक बार यहाँ पार्टिसिपेंट से पूछना चाहूंगी, देयर इज एनी क्वेरी फ्रॉम योर साइड? मैम ने इतना अच्छा बताया है कि अब ये करके देखेंगे मैम। तो अब इसकी क्वेरीज समझ में आएंगी और फिर ये आप जब नेक्स्ट लेक्चर लेने आएंगे तो डेफिनेटली कुछ ना कुछ लेके आएंगे आपके पास। थैंक यू सो मच मैम।
Thank you so much. I'm always there to help.
क्वेश्चन पूछना है अभी सर? मैम एक क्वेरी आई है हमारे पास, एचएन सिंह सर ही पूछना चाहते हैं जी। माइक
बुला लीजिए, स्टेज पे बुला लीजिए डॉक्टर सोनिया।
प्लीज कम है, यहीं पे आके
Ma'am, I am a physicist. So when I go through the derivations in the class, we student frequently ask the question कि sir याद भी करना पड़ेगा और ये भी तो I would like to know कि how to convince them कि what is the importance of derivations.
Derivations of what?
Derivations of anything, either we derive a theorem or a lemma, or in physics we derive whatever the formulae. So once the formula is little bit lengthy in derivation, students are scared कि इतना याद करना पड़ेगा, और ये कहीं ऐसा न हो, ऐसा तो नहीं कि हम सिर्फ फाइनल रिजल्ट याद कर लें। वो
जी
फ्रॉम
इस
अप्लाइड
बात
पॉइंट ऑफ व्यू ठीक है।
हाँ, इस बात में मैं एक बात कहना चाहूंगी कि
हाँ,
देखिए मैंने अभी भी आपको जो फॉर्मूला बताया तो आप मैंने डिराइव करके बताया, उसमें याद करने की जरूरत नहीं थी। जो हमारा
हाँ,
यूजुअल मेथड है उसी को मैंने अप्लाई करके वैदिक गणित में लेके गई। अगर इसी तरह से हम स्टूडेंट्स को बताते हैं तो उनको याद करने की जरूरत नहीं होती। एक बार उनको जो चीज समझ आ जाएगी ना, पूरी लाइफ लॉन्ग वो याद रखेंगे। तो ये बेसिकली हम टीचर्स में कमी है कि हम उनको हर चीज याद करने की तरफ झुकाव उनका हमारा रहता है। अगर हम उनको बताएं कि डेरिवेशन ऐसे ऐसे चलेगी स्टेप बाय स्टेप, और यही आगे चल के उनको रिसर्च में काम आती है। जब ये
Right.
बात वो इम्बाइब कर लेंगे ना तो उनको पता चल जाएगा रिसर्च के स्टेप्स भी यही है, उसमें भी कोई खास बड़ा कोई ना वो नहीं है, रहस्य नहीं है।
हाँ,
तो
मीन्स
ये
जो हमारे डेरिवेशन के स्टेप्स हैं, वी शुड कंपाइल लाइक दिस एज ए ट्रिक, कि ये कैसे हम रीजनरेट कर सकते हैं।
जी जी जी
दे विल बी
बिल्कुल। हाँ,
कंफर्टेबल।
तो
हाँ,
इसलिए
थैंक
मैं
यू।
जब भी वैदिक मैथ्स पे लेक्चर देती हूँ ना, मैं ट्राई करती हूँ कि जो हमारा यूजुअल टेक्निक है उसको कनेक्ट करूं वैदिक गणित से, ताकि उनको दोनों में सामंजस्य पता चले कि कैसे कोऑर्डिनेशन है इन दोनों में।
यस मैम, थैंक यू सो मच। थैंक
आई होप यू रिजॉल्व योर क्वेरी।
यस मैम, यस डेफिनेटली। मैम इसमें मैं एक चीज़ और इंक्लूड करना चाहूँगी, जैसे कि कल जब भाटिया सर आए थे, तो भाटिया सर ने भी कुछ यही जो आप पूछ रहे थे सर, उन्होंने भी कुछ ऐसे ही बताया था कि हम गणित और वैदिक गणित को अलग-अलग ना समझें। हम दोनों को मर्ज कर दें, तो बहुत सारी चीज़ें जो हम टिपिकल समझते हैं, उनको हम ईज़ी बना सकते हैं। और यही ऐसा ही मैम ने आज करके भी दिखाया आपको। जो डेरिवेशन जो मैम ने करे हैं, वो ऊर्ध्व तिर्यक व्यायाम को कैसे अप्लाई किया जा सकता है, वैदिक मैथमेटिक्स का एक सूत्र मैम ने अप्लाई करके दिखाया, और उससे डिफरेंशियल और इंटीग्रल कैलकुलस के जितने फॉर्मूले हैं या जितने डेरिवेशंस हैं, आप उसको बहुत ईज़ी मेथड से आप कर पा रहे हैं, जनरेट कर पा रहे हैं। थैंक यू सो मच मैम फॉर सच अ वंडरफुल एंड इन्फॉर्मेटिव लेक्चर वंस अगेन।